So the idea here is we're just going to take the derivative of each piece separately, each piece that's separated by a plus or a minus sign. Now the only thing that's a little bit wonky is that typically we think about y as a function of x here. So if I look at x to the 5, that's already a function of x. So I can just take the derivative of x to the 5, and that's 5x to the 4. And negative 7 is also a function of x, so I can just take the derivative of negative 7. We know that's 0. This is a horizontal line. It doesn't really have, it has a slope of 0. The tricky part is thinking about y to the 6. So y to the 6 is technically a function of x. So if y to the 6 is a function of x, right, if we think about this as a function of x, then the chain rule says if I take the derivative of this with respect to x, I should be taking the derivative of f with respect to y, and then multiplying by the derivative of y with respect to x. So that's what the chain rule is going to say here, because we're going to think about it as a function of x. We know the derivative of y to the 6 is 6y to the 5. So we're going to get 6y to the 5. So that's this part. And then we're going to multiply by dy dx. We don't actually know what that is. That's what we're trying to solve to answer this question. So there we go. That's kind of the setup for these questions, is kind of viewing any function of y as a function of x and understanding that the dy dx comes out because of kind of our setup with regards to the chain rule.
Seta, indecisive.
Oh, interesting.
If you're uncertain, break it down like a complex problem. What factors are affecting your equation? Identify them, and let's find the solution.
Now, my thought there, so, I mean, to finish off this question, we're just going to take the 6y to the 5, we're going to divide that through on both sides. Now we have an expression for our derivative, and our derivative typically is going to involve both x's and y's. So that's very typical for these kinds of questions. Okay, let's take a look at this one. We got 4x squared plus 2x plus xy. That's going to be tricky, equals to 2. This is going to be the tricky one. Everything else seems reasonably okay. I think I can take the derivative of all of these other pieces in a relatively simple manner. So 2 is a horizontal line, slope 0. 4x squared, the derivative of that's going to be 4 times 2, which is 8x. The derivative, this is a line, so 2x is a line with slope 2, so its slope is going to be 2. It's going to be this piece here that I'm a little bit concerned about. This is a product of two things, so I need to use the product rule in order to get this work done. So I need the derivative. I need the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. Now, we can rewrite y, well, I guess they're using y prime in this particular notation, so maybe we can keep y prime, so we have something like 8x plus 2 plus y plus x y prime is equal to 0. They want us to eventually find y prime evaluated at 2. So what does this actually mean? This means sub x equals 2 into y prime. So we could do that, theoretically. We could say, okay, well, let's just sub 2 in, and we get something that looks like this. And what you're going to notice is that when we sub that x equals 2 in, we're going to be left over with this extra y bit, and we're not going to really know what to do with that immediately. Right, so that's kind of the issue that we're going to run into. If we just blindly sub x in, we're going to land on something that looks like this. So how do I figure out what this y value is going to look like, well, we need to think about y as a function of x, right? So this y is actually a function. Well, I shouldn't say a function. It's a relationship that will depend on x. So we have a relation here between x and y that we might be able to use to get the job done. So we know that we had an original relationship that 4x squared plus 2x plus xy was equal to 2. So this was a relationship between x and y. And if x was 2, then we'd have 4 times 4 plus 2 times 2 plus 2y is equal to 2. So I could sub x into this relationship. And maybe I could figure out what y equals to. So we know, for example, that 20 plus 2y is equal to 2. We know that 2y is equal to 2 take 20, so negative 18, and y should be equal to negative 9. So if we sub that back in, we'll get 18 take 9 plus 2y prime is equal to 0. Eighteen take 9 is 9. And maybe I should be a little bit careful about my notation here. Technically, as soon as we have subbed x equals 2, and this is technically now y prime at 2, isn't it? So technically, these are now y primes evaluated at 2. Right, so what I really have way down here is 2 times y prime at 2 should be 9. So I know that y prime at 2 should be 9 over 2, or 4.5. Find the slope of the tangent line to the curve. So we're in the same situation as before, only now we're kind of playing a little bit with fire here. We have not only a product rule to work with, but we have a chain rule to work with as well. So let's think about this chain rule first. So if I say that f is negative 4y cubed, and I want to find the derivative of this thing with respect to y, I would say that this is the derivative, if I want to find this with respect to x, which is what we're going to try to do, then I want the derivative of this expression with respect to y times the derivative of y with respect to x. So what I need is negative 4. We're going to get 3y squared times dy dx. So that's going to be my f prime. And that's what I'm going to need to talk about this piece here. All right, so let's just remember that when we start working on our derivative. So the derivative of this piece, 4 times 2, and then we'll subtract 1 from our power. The derivative of this piece we just saw up above, which is going to be the derivative of x times y plus the derivative of y times x. We know the derivative of this next piece. Maybe I'll pull this down a little bit. Should be negative 12y squared y prime. Right, dy by dx, we can rewrite that as y prime. And then finally, 6 has a slope of 0. So we're looking at something that looks kind of like this. Let's try to simplify some stuff up and see what happens. So the derivative of x is just 1, so we should get 2y plus 2xy prime minus 12y squared y prime is equal to 0. And so now we know that we're working with a particular point. We can actually substitute that point in. Let's try to find y prime evaluated at x is equal to 1. So let's do x equals 1, y equals minus 1, and try to solve for this y prime. So 8 times 1, 2 times negative 1 is going to give us negative 2. And then we have plus 2y y prime, and I'm going to leave a little bit of a gap here because I want to write this properly. Y squared is going to be 1, and then y prime equals 0. So this particular y prime is going to be happening when x is equal to 1. So I'm going to call this y prime at 1. And then we can go ahead and start simplifying some stuff. So we get something that looks like this. Let's move the 6 over to the other side to get a minus 6. And then I have 2 y primes minus 12 y primes. That should be negative 2 take away 12 is negative 10. So I have negative 10 of those things. So that y prime evaluated at 1 should be 6 on 10, which if we divide by 2 should be 3 on 5. So that should be the slope that we're looking for at this particular point, 1, negative 1.